we're going to look at R16, and it's about definite integrals and some other things that have to do with that using the fundamental theorem of calculus. So make sure you know all the integration rules. Look for inverses, trig functions, u substitution, log, and exponential functions. So the homework is going to be Barron's look at those. The second part of the fundamental theorem of calculus says taking the derivative of the integral gives you back the derivative. So remember that. That's going to be important. And finding the area of regions under a graph using geometry. We've done that a lot in FRQs. Remember, the stuff under the x-axis is going to be negative. And then be able to add and subtract integrals with various limits to create new equivalents. So that's example 12. So let's just go over the examples. So the first one says, hey, take the derivative of this integral. And so you look first at your endpoints, and you have -1 to x. So you have just an x. So it's taking the derivative of an integral, which just means you get this back, and you replace t with x. So you get the square root of 1 plus sine squared x instead of t. That's that fundamental theorem of calculus. Now, this doesn't have a baby because the baby of x is 1, but it might if it's a bigger function. So let's look at number 2. You have the derivative of x to 1 of this function, and you can't do that. The x has to be up here, so you're going to flip it, d dx of -1 to x. Keep the function the same. And so now it has a baby of 1. Don't forget the negative out in front, though, because you've changed it. Okay, so e to the -x squared instead of t squared. So no baby here either, just had to flip it. Let's go on and look at number 3. You have the first one that looks like you have a function that's not an x here. So they just, I rewrote this derivative of the integral of 1 to x squared of 1 over 3 plus t dt. So it's like your normal, you would replace t with whatever's up there, so that's the 3 plus x squared, but then remember you have to multiply it by the baby of your endpoint, so you multiply that by 2x. So look for this to be somewhere. So you get 2x over 3 plus x squared. Derivative of the integral gives you the derivative. You might have babies. Okay. Here's one with a trig function. It's the same thing, except this does, please remember that has a baby, right? The derivative of cosine is negative sine. So you would put, I just rewrote it because it could ask like this, f of x is this, find f prime of x. So you have to know that means, hey, put the derivative in front to see that it, remember it's, oh, that's just equal to what that is. So I rewrote it, and so then I put in the cosine instead of t, so I got the cosine cubed x, and then I have to multiply it by negative sine x because that's the baby of cosine. So chain rule. Okay, don't forget the chain rule for this. So you get negative sine x square root of 1 minus cosine cubed x. Number 5. Okay, I'll start a different video because this is a little different.